A routine batch test in a processing plant reveals a bacterial count just above a regulatory threshold. Within minutes, the lab flags the anomaly. But what happens next depends entirely on where that factory stands. In one region, the product can't leave the building. In another, it might stay on shelves for days. The same data, the same hazard. 3 different interpretations of risk. Here's the first quiet truth. FDA, EFSA, and CFIA all measure danger using similar tools: microbial counts, chemical limits, exposure models. But the actions that follow those measurements diverge. Each agency operates under a distinct philosophy, shaped by decades of legislation, crisis responses, and scientific advisory structures. And those philosophies determine how fast a risk becomes a recall. In the United States, the FDA focuses heavily on verification. When a potential hazard surfaces, investigators look for confirmation, repeat samples, historical data from the facility, and evidence of cross-batch contamination. That process protects against false positives, but it adds hours, sometimes more than a day, to the timeline. In food safety, a day is long enough for thousands of units to move downstream. Across the Atlantic, EFSA works with a different principle. The precautionary approach favors early intervention. If a contaminant appears above a reference value, even by a narrow margin, European authorities often initiate action while confirmation runs in parallel. A deviation of just a few parts per million in a chemical test, or a microbial spike above a reference value, can trigger immediate distribution blocks. It's a system optimized for speed, built on the idea that acting a little early is safer than reacting a little late. Canada's CFIA fits between these models. Its classification tiers define urgency. A confirmed pathogen with a low infectious dose falls into the most critical category, triggering instant national coordination. But borderline cases, those requiring more context, environmental investigation, or trend data, move through stepwise escalation. It's structured, systematic, and sometimes slower than EFSA, but often faster than FDA, depending on the nature of the hazard. These differences reveal a hidden mechanism. Regulatory thresholds don't just measure safety, they shape response time. A temperature drift of only 3 degrees in a cold room might be considered a minor deviation in one jurisdiction, but a major noncompliance in another. A pesticide residue measured in micrograms per kilogram might fall within tolerance in North America, yet exceed limits in Europe due to stricter cumulative exposure models. And that's where the first value spike emerges. Even when regulators examine identical data, their definitions of risk aren't aligned. An additive approved after extensive toxicological review in one system might remain restricted or require additional labeling in another. A pathogen test with a borderline cycle threshold might trigger surveillance in one jurisdiction, but a recall in another. Consumers rarely see these distinctions, yet they influence everything, from reformulation decisions to which products cross borders. Inspections expose the next contrast. FDA inspections follow risk-based cycles. Some facilities might go a year or more without an on-site evaluation unless flagged. EFSA oversees a network of national authorities, meaning inspection frequency varies across countries, with some plants inspected multiple times per year and others less consistently. CFIA conducts frequent checks in sectors known for higher contamination potential, especially meat and dairy, sometimes inspecting sites weekly, depending on classification. Each architecture creates strengths and blind spots. Less frequent inspections can miss emerging issues. Uneven national enforcement can create inconsistencies. High-frequency models demand more resources, but catch small deviations sooner, like condensation patterns, equipment drift, or microbial trends that grow detectable only when multiple samples across a week show upward movement. Additives and chemical limits reveal another fracture line. EFSA often bases limits on lifetime exposure models, setting stricter thresholds for compounds that accumulate. FDA commonly harmonizes limits with existing industry standards and historical toxicology data. CFIA evaluates both sets of models and may adopt whichever appears more protective for specific categories, particularly in products imported from regions with known contamination risks. Recalls make these differences tangible. In the U.S., recalls are almost always voluntary, even though the FDA has mandatory recall authority. The system depends on cooperation, which can introduce delays measured in hours or days. In Canada, CFIA routinely issues direct public advisories once a risk classification is confirmed. In Europe, recall decisions move through member state channels, allowing multiple countries to respond within hours of a shared alert. 3 different frameworks, 3 different speeds, 3 different levels of precaution. Here comes the reversal. There is no single best system. Each model excels in certain scenarios. Precautionary systems act quickly, but can over-trigger recalls. Verification-heavy systems prevent unnecessary disruption, but risk acting too late. Tier-based systems balance urgency with structure, yet may stall when evidence doesn't fit cleanly into a category. When viewed together, they reveal something deeper. Food safety isn't one shield, it's a network of overlapping protections shaped by politics, science, economics, and national priorities. Consumers live in the space between these choices, often unaware that the same product could be considered safe in one region and restricted in another. As pathogens evolve faster, supply chains tighten, and detection technologies deliver results in minutes instead of days, these regulatory philosophies will be tested again. They'll face pressure to harmonize, to accelerate, to justify standards once defined by slower systems. And that raises the open question. If 3 of the world's most advanced regulators interpret safety differently today, what happens as hazards grow more complex, microbial, chemical, digital? Somewhere in those differences lies the future of trust. A future shaped by the choices regulators make, quietly, urgently, and often unseen.